Hello friends, I welcome you all again to my video lectures. This has been quite a while that I have uploaded a video lecture. In the last video lecture, I have told you about the divisibility rules of 2 and 3. Now, in this video lecture, I will continue from where I left last. That is, after divisibility rule of 2 and 3, I will explain to you in detail the divisibility rule of 4. And I will try to reach as much far as I can. So, starting with divisibility rule of 4. Now, what does this divisibility rule of 4 says? Suppose there is a number. Number is something like this, ABCD. And if I have to check that whether this number ABCD is divisible by 4 or not, then how I am going to do it? So what the bookish definition says, that we will pick up the last two digits of this 4-digit natural number. That is, the last two digits are 4, this C and D. So I will write here C and D. And I will check whether this C and D is divisible by 4 or not. And if this C and D comes out as divisible by 4, then I will sum up that this 4-digit number is divisible by 4 also. That is, if this CD is divisible by 4, then this number is also divisible by 4. And if this CD is not divisible by 4, then this number ABCD is also not divisible by 4. This is what the bookish definition says. The bookish definition says that for the divisibility rule of 4, we have to do this in this manner, that we have to check for the last two digits. If the last two digits are divisible by 4, not divisible by 2. If the last two digits are divisible by 4, then only the whole original number will be divisible by 4. And in this way, you can also say that if there is a 4-digit number and if you want to find out that what will be the remainder when that 4-digit number is divided by 4. Suppose this is the 4-digit number here, ABCD, and I divide this ABCD by 4. And now I have to find out that what will be the remainder when I will divide ABCD by 4. So if this ABCD is not divisible by 4, then automatically it will make out some remainder. That remainder can be 1 or 2 or 3. So if I have to find out the remainder when ABCD is divided by 4, what will I do? I will pick up the last two digits of this number ABCD, that is CD, and I will divide this CD by 4. And whatever remainder this CD will give when divided by 4 will be the remainder this 4-digit number ABCD will give when divided by 4. That is, remainder when this number ABCD is divided by 4 is equals to remainder when this number CD is divided by 4. These two are basically the same things. That is, it goes same for the 4-digit number, it also goes same for the last two digits, that is C and D here. This is the whole point here. I hope this much amount is clear to you. Now, after telling you this much, I am going to tell you why this rule is applicable. That is, why only by checking for the last two digits I am able to sum up the divisibility rule of the whole number. So in order to look at that thing, what was the number? The number was something like this, ABCD. I have to check the number, divisibility of this number ABCD by 4. Now, I am going to write this number ABCD something like this. 10 cube into A plus 10 square into B plus 10 into C plus D into 10 to the power 0, that will become 1. That is why I have written only D. Or you can write it also D into 1. Into 1 means D into 10 to the power 0 and 10 to the power 0 is 1. I have told that to you already before. So, divided by 4. Let us find out that whether this number ABCD is divided by 4 or not. So, this whole expression and this whole expression, these two are the same things only. Now what's the basic difference? Look at this thing, 10 cube into A plus 10 square into B plus 10 into C plus D into 1. If I'm going to divide this expression, now I have already told you the basic concepts of remainders, that is, I will find out the individual remainder of this term, 10 cube into A divided by 4, write it here. Then I will find out the individual remainder of 10 square into B divided by 4. Then I will find out the individual remainder of 10 into C divided by 4 and then D by 4. So first I am going to find out what is the individual remainder when 10 cube into A is divided by 4. So what is 10 cube? 10 cube is 4000. Sorry, 1000. Is 1000 divided by 4? Yes. 4 into 250 is 1000. So this number 10,000 is divided by 4. So the remainder will be 0. And when this number A is divided by 4, I don't know the value of A. So I write this down as A only. So these were the two terms, 10 cube into A. There was a multiplication sign in between. I divided 10,000 by 4. It was totally divisible. So the remainder is 0. When I divide by A by 4, I don't know the value of A. So I simply wrote down that A is the remainder. And what will be the sign in between this multiplication? Because in between the original numbers, the sign is multiplication. So here also multiplication. So what will be the final outcome? 0. So the remainder of 10 cube into A when divided by 4 is 0. Coming on to 10 square into B. Multiplication sign. B divided by 4, remainder B. 10 is square, that is 100 divided by 4. 100 is divisible by 4, so remainder 0. Multiplication sign, overall remainder 0. Now, coming to this point, this expression 10 into C plus D into 1. When 10 is divided by 4, what is the remainder? 2 is the remainder. That is, this 10 is not exactly divisible by 4. So, I cannot say that when this 10 into C is divided by 4, the remainder will be 0. I cannot say that. In these cases, I said this because this 10 cube was exactly divisible by 4. This 10 square was exactly divisible by 4. But in this case, 10 into C, this 10 is not exactly divisible by 4. It is leaving a remainder of 2. So I cannot say that this 10 into C will leave a remainder of 0 when divided by 4. So this is why the divisibility of this 4-digit number or the remainder of this 4-digit number, both are the same things. Of this 4-digit number ABCD when divided by 4 will depend upon these two expressions. That is on 10 into C plus D. So it will be something like this, that if 10 into C plus D is divisible by 4, then this whole number will also be divisible by 4. And what is this 10 into C plus D? This is the 2-digit number CD. I hope now you are getting the point. This is the reason that in the divisibility rule of 4, we take the last 2 digits and check the divisibility by them only. When it comes to the remainder, I told you the second point, that you have to find out the remainder when a 4-digit number ABCD is divided by 4. So in that case, the remainder will be same if the last 2 digits of this original number, that is if CD is divided by 4, the case that when CD, the remainder that CD will give when divided by 4, that remainder will be same to the remainder that this 4-digit number ABCD will give when divided by 4. Because in this case, these first two expressions are giving a remainder of 0 only. So 0 plus 0 is 0 only. So on what quantities is the remainder of ABCD when divided by 4 depending? It is depending on the last two numbers, that is CD, that is 10 into C plus D. The last two numbers are CD, that is it is a 2-digit number CD, and CD can be written as 10 into C plus D. So the divisibility of this 4-digit number or 5-digit number or 6-digit number or 7-digit number is totally dependent upon the last 2 digits, and also the remainder of the original number by 4 also depends upon the last 2 digits only. This is the whole concept. So I think that this divisibility rule of 4 is a bit clear to you. You can relate it to divisibility rule of 8 also. Now, before moving on to the divisibility rule of 5, I will like to tell you the divisibility rule of 8. I am skipping the divisibility rule of 6 and 7. I will tell you to them later, because each and every divisibility rule has its own properties, has its own method of solving. So I would like to proceed in a more, you can say, a lucid way, a very clear way, so that everything is clear to you. Coming to rule of 8. Now, the point here is, I told you the divisibility rule of 2. I told you the divisibility rule of 4. What was the basic feature of the divisibility rule of 2? In the divisibility rule of 2, I told you that the unit digit should be even. That is either 0 or 2 or 4 or 6 or 8. That was the divisibility rule of 2. And that is, in the divisibility rule of 2, I can also say that the last digit should be divisible by 2. So the divisible by 2 digits are 2, 4, 6 and 8, and I will also consider 0 in that. So in the 2-digit divisibility manner, I used that the last digit is an even number. You can say that an even numbers are 2, 4, 6, 8 and 0. In the case of 4-digit divisibility, that is divisibility by 4, I checked by the last 2 digits. Now I told you the proving of these two also. That is, I factorized the original number and the detailed proving of both the divisibility rule of 4 and divisibility rule of 2 I have told you. Let us take it by an example also. Suppose this is a number 5, 4, 6, 8. If I have to check the divisibility rule of this number by 4, that is divisibility of this by 4. So I don't need to check with the whole number. I just need to take up this 6, 8. And I will check the divisibility of this 6, 8 by 4. And this 6, 8 is divisible by 4. So this whole number 5, 4, 6, 8 will also be divisible by 4. This was what I am trying to tell you. And if this is a number 3, 6, 7, 9 and 8. This is a 5-digit number. If I divide this number by 4 and I need to find out that what will be the remainder when this number 36,798 is divided by 4. So in order to find out the remainder when this number 5-digit number 36,798 is divided by 4, what I need to do? I do not need to divide this whole number by 4. I just need to pick up the last two numbers, that is 98. So I picked up 98 and I put here 98. Now the point is that I have to just check the divisibility or the remainder which will be obtained when this number 98 will be divided by 4. That is, in order to find out the remainder when this whole 5-digit number is divided by 4, I do not need to divide this whole 5-digit number by 4. I just have to divide the last 2 digits of this number, that is 98 by 4. And whatever remainder this 98 will leave by dividing by 4, that remainder will be equivalent to the remainder that this 5-digit number 36,798 will leave when divided by 4. This is what I am trying to tell you. The remainder here will be 2. So the remainder here will also be 2. Now, coming to divisibility rule of 8. Connecting these two things, I am trying to say this thing in months. For divisibility rule of 2, 1 0. For divisibility rule of 4, 2 zeros. And for divisibility rule of 8, 3 zeros. Now what does this mean? I take a big number in this. I, A, B, C, D, E. 5-digit number. I have to check the divisibility rule of this 5-digit number by 8. Again, factorizing this 5-digit number, what I will write? I will write AB into 1000 plus CDE. Now what is this? I can write this ABCDE as AB into 1000 plus CDE. How I can write this? Have a look. This is a number something like this. 54894. 54,894. I can compare this number to this number. This is also 5-digit number ABCDE. This is also 5-digit number. How can I write this 5-digit number? I can write this 5-digit number something like this. 54,000 plus 894. The point is, in the divisibility rule of 8, in order to understand this divisibility rule of 8, what I did, I considered the last 3 numbers of the original number separately. In the divisibility rule of 2, I considered only one last number, that is the unit number. In the divisibility rule of 4, I considered last 2 digits, that is the unit digits and the tens digits. In this divisibility rule of 8, I consider the last 3 digits, unit digits, tens digits and hundreds digits. So 54,894, I wrote it down as 54,000 plus 894. Now, this is same like this, that if I have written ABCD divided by 8, you can, in order to show you this, if any of you is not able to understand that why I have written this ABCDE equals to AB into 1000 plus CD, the reason for that is because this 54,894, we can write this 54,894 as 54,000 plus 894. This is the method of writing this thing, because this is decimal notation. It's very simple. In order to factorize this thing, I have to take the number of zeros, the number of that powers up to the power 10, because this is in the base 10. I can also write this number ABCD as something like this: A into 10 to the power 4 plus B into 10 cube plus C into 10 square plus D into 10 plus E. I can also write this as something like this. So what is this? A to the power 4 plus B into 10 to the power cube. This is AB into 1000. And what is this? C into 10 square, D into 10 plus E. This is CD. So here, this thing. Checking the divisibility rule of divisibility of these two numbers by 8. Divide this number by 8. 1000. 1000 consists of 3 zeros. 1000 by 8. Is 1000 divisible by 8? Yes. 1000 is divisible by 8. So what will be the remainder? 0. This is a two-digit number AB. I don't know at this point of time that what will be the remainder of AB will 8. But it doesn't matter. Whatever the remainder AB leaves with 8, doesn't matter, because between AB and 1000 there is a multiplication sign. So there is also a multiplication sign between 0, that is the remainder of 1000 by 8, and this quantity. This quantity is the remainder when this two-digit number is AB is divided by 8. So whatever this quantity is, and between this 0 there will be a multiplication, and this overall value will come out as 0. So the remainder when AB into 1000 is divided by 8 is 0, because there is a 1000 in S, and when 1000 is divided by 8, the remainder is 0. So obviously that 0 will be multiplied by the remainder that this two-digit number AB will leave when divided by 8, and the final remainder will be 0 only. Coming to this point, CD. So if this remainder has came out as 0 plus, then automatically the divisibility of this number by 8 will depend upon these three numbers, that is CD. That is, if this CD are divisible by 8, then we can say that this whole number, 5-digit number, is divisible by 8. So whether it is a 5-digit number, whether it is a 6-digit number, whether it is a 7-digit number, whether it is a 8-digit number, doesn't matter. 100-digit number, 200-digit number. If I have to check the divisibility of that number with 8, I have to check for the last 3 digits only. This is the whole logic behind this thing. For the last 3 digits only. I hope you are getting my point. That is, if the CDE leaves a remainder of 0 with 8, then we can say that 0 plus 0 equals to 0. That is, the remainder is 0. That means this number ABCD is divisible by 8. I should take the example by this thing. 54,000 plus 894 divided by 8. If I have to check the divisibility rule of this number, 54,894 by 8, I wrote the down as 54,000 plus 894. What is the remainder when this 54,000 will be divided by 8? It will be 54 into 1000. 1000 is divisible by 8, so the remainder is 0. And multiplying 0 by 54 will be 0. So the remainder of 54,000 by 8 will be 0. What will be the remainder when this number 894 will be divided by 8? What will be the remainder when this number 894 will be divided by 8? So just calculate it. 8 ones are 8. Next, 8 ones are 8. 8 ones are 8. The remainder will be something like this, 666. So, what will be the answer? 0 plus 6. So, the remainder when 54,894 is divided by 8 is 6. How did I do it? I wrote it down as 54,000 plus 894. And the point is, there is no need to write down this 54,000. You just need to pick up the last three numbers. That is 894. Divide 894 by 8. Whatever will be the remainder will be the remainder when the original number will be divided by 8. I think the point is, I am trying to tell you this thing in two different ways. That is in the form of divisibility and that is in the form of remainder. Because these two things are the same thing. If a number is divisible by some other number, then obviously the remainder becomes 0. If this ABCD is divisible by 8, then the remainder when this ABCD will be divisible by 8 will be 0. These two things are the same things. So, if the CD is divisible by 8, then this whole number is divisible by 8. And if I have to find out the remainder of this whole 5-digit number ABCDE by 8, that remainder will be equal to the remainder when this number CDE will be divided by 8. I hope you are able to correlate the divisibility rule of 2, 4 and 8. This is my whole effort in this video lecture. That is, I want to make you sure that in order to, you should be able to correlate the divisibility rules of 2, 4 and 8. Now, if you are able to correlate, you can easily understand the divisibility rule of 16, the divisibility rule of 32, the divisibility rule of 64, the divisibility rule of 128. Have a look. 2 to the power 3, 8. 2 square, 4. 4, 16. 5, 32. 6, 64. 7, 128. 8, 256. Divisibility rule of 2 and 4 and 8 I have already discussed. These three divisibility rules have been discussed. Coming from this, 16, 32, 64, 128, 256. The property is that the divisibility rule property that I have used in this, the divisibility rule of 2, 4 and 8 is pretty much similar to the property that will be used in the divisibility rule of 16, 32, 64, 128, 256. That means that in the case of 2, divisibility by 2, I check the last number. What does the last number correspond to? 1, 0. In the divisibility rule of 4, I check for last two numbers. What the last two numbers correspond to? 2 zeros. In the divisibility rule of 8, I check for last three numbers. What does the last three numbers correspond to? 3 zeros. Now coming to the divisibility rule of 16. Suppose A, B, C, D, E, F. This is a 6-digit number. I can write this number as AB into 4 times 0 plus CD, EF. I hope that writing in this manner is a bit clear to you now. If you are going to multiply AB into 10,000 plus CD, EF, you are going to get this number. Now if you are going to check this divisibility by 16, how many 2's are there in 16? 4 2's. That is 2 to the power 4 is 16. So in 16, 4 2's are there. And how many 10's are here? You can also write this 10,000 as 10 to the power 4. That is 4 10's are here. And how much is 1 10 is equals to? 1 10 is equals to 5 into 2. That is, if in this expression 4 2's are there, because 10 to the power 4 will be equal to 5 to the power 4 into 2 to the power 4. So, if this 10 to the power 4 consists of 4 2's, and in the denominator there is also 4 2's, because divisibility by 16 is pretty much similar to this, 2 to the power 4. So obviously this number will become divisible by this, and the result will depend upon this number. How many digits are there? C, D, E, F, 4 digits. So for this reason we say that the divisibility by 2, 1 digit, divisibility by 4, 2 digits, divisibility by 8, 3 digits, divisibility by 4,